guys, Janine here, and in today's video we are going to be learning how to solve a first order linear differential equation. So a first order linear differential equation can be written in the following form. So we have dy over dx plus p of x times y is equal to f of x, where p of x is just a function of x and f of x is just another function of x. And so this form is called standard form, and it is important because this is the form that we'll be using to solve our first order linear differential equations. So the first step to solving this type of problem is to put our differential equation in standard form. So this form here. And our next step is to find our integrating factor, which can be found by the following formula. So we have the integrating factor is equal to e to the p of x dx, and p of x is just this function here that is a function of x multiplying y. And the next step is that we're going to want to multiply the entire differential equation by the integrating factor, because the resulting equation can be written as the derivative with respect to x of the integrating factor times y, and that is equal to the integrating factor times f of x. So f of x is just this function here to the right hand side of our equation when our equation is in standard form. And the last step is to integrate and solve for y. So let's go ahead and take a look at an example. So in this example here, we have x squared y prime plus xy is equal to 1. So let's start out by putting our equation in standard form. So we can rewrite this as x squared dy over dx plus xy is equal to 1. So we can see here that this is not in standard form because we have this x squared term multiplying the dy dx, and that's not present in the standard form. So let's go ahead and multiply this entire equation by 1 over x squared. So doing that, we get dy over dx plus 1 over x times y is equal to 1 over x squared. And then from here, we can go ahead and identify what our p of x is. So p of x is equal to 1 over x. And so from this form here, we can tell that our function is not defined at x equals 0. So we can go ahead and define our interval of definition to either be negative infinity to 0 or 0 to positive infinity. And for simplicity, let's go ahead and pick this interval here. Okay, so the next step is to determine what our integrating factor is. So let's do that. So our integrating factor is equal to e to the integral of p of x, which is 1 over x, dx. And this is just equal to e to the ln of x, and we can leave out the absolute value sign because we have picked this interval here. Okay, so the e and the ln x simplifies down to just x. So that's our integrating factor. And then the next step is we want to multiply the entire differential equation by the integrating factor. So let's do that. And so the left-hand side of our equation just ends up being the derivative with respect to x of the integrating factor times y. So we end up with the derivative with respect to x of x times y is equal to 1 over x. And from here, we can go ahead and integrate both sides of our equation. Okay, so these two cancel out each other, and we're just left with x times y is equal to the natural log of x. Okay, and don't forget the plus c. And so the last step is to solve for y. So we're going to go ahead and divide both sides by x. And we get y is equal to the natural log of x plus c over x. And that is our final answer. And so that is how you solve a first order linear differential equation. Thank you guys so much for watching. If you guys have any suggestions on what types of videos you guys want me to do next, just leave them in the comments down below. And I'll see you guys in the next video. Bye.